Hello guys, my name is Craig and welcome to Payment Solutions. Today we shall start on integration, being the reverse process of differentiation. But before we start, if you're new to my channel, please make sure you hit the subscribe button and don't forget to turn on the notification bell so that you don't miss out on any videos. So to start off, what we have to know is that, or what we already know is that, say we've got our function y is equal to 3x squared minus 5x. Right. So what do we know? We know that dy by dx would be equal to 6x minus 5. Right. And then now say we've got another function. Right. And then this function is a bit different. Say we've got y is equal to 3x squared minus 5x plus 6. Or even plus 7, plus any constant, plus 100, plus whatever constant that we choose. Right. What we still know is that dy by dx would be equal to 6x minus 5. Right. So now what does this imply? This implies that if we've got dy by dx being equal to 6x minus 5, let's say we've got our dy by dx being equal to 6x minus 5, right? We can have a function of y such that y is equal to 3x squared minus 5x plus a constant c, right? So what we are doing is that we are working backwards. From this derivative, dy by dx, we are coming up with y being the equation. Right. So what we are basically saying is that we are reversing the process of differentiation to get this integral. Right. So this is what we call integration. Integration being the reverse process of differentiation, such that if we've got say we've got dy by dx being equal to x to the power of n. Right. What we are saying is that if we integrate x to the power of n with respect to x, right? Now we want to find the original function or the equation of the curve for dy by dx. We are saying the integral of x to the power of n with respect to x, this would be equal to x to the power of n plus 1 over n plus 1. N, of course, being the power, and now this is only valid when n is not equal to minus 1, right? So this is the general form of how we find the integral of x to the power of n. We simply say x to the power of n plus 1, we add 1 to the power, then we divide by the power plus 1, right? So now I want you to relate. With differentiation, we said basically we are dropping the power, multiplying, then subtracting. So the phenomenon that we're using is that we're basically multiplying and subtracting. Now with integration, it's actually dividing then adding here, right? So it's division then addition. Differentiation, multiplication, then subtraction. Okay, so now I haven't talked about the general form of how we find the integral. Now I would like to attempt these questions, these 10 questions that require us to find find y given dy by dx, right? So allow me to erase this part. Yeah. Okay, so let's start. For the first one, number 1, we're given that dy by dx is equal to 2x, and we're required to find y. So we said y would be the integral of 2x with respect to x, right? But what we also have to know is that 2 is just a constant, so we can even take it out such that we've got 2 integral of x with respect to x. This is x to the power of 1. So we said here we shall say 2 times x to the power of 1 plus 1, we get a 2, over 1 plus 1, which is 2. And then this and this will cancel, plus the constant c, which we call the constant of integration. So here we shall get x squared plus c. If you want to prove this result, we simply differentiate and see if we get back here. All right, for number 2, we are saying that we want to find the integral of x to the power of 7 with respect to x. So here we're simply saying x to the power of 7 plus 1, that is 8, over 7 plus 1, that is also 8, plus the constant of integration c. And then number 3, we want to integrate 10x plus 8x to the power of 7 with respect to x. So now we are saying that, so we say there's x squared plus a c, then this is x to the power of 8 over 8 plus c. So we are now number 3. Now with number 3, we're saying that if we take out the 10, we're simply saying 10 times the integral of x to the power of 1. This is x to the power of 2 over 2, then plus 8 multiplied by the integral of x to the power of 7. This will be x to the power of 8 over 8, plus the constant of integration c, such that 2 into 10 we get 5. Then this will give us 5x squared plus 8 and 8 will cancel, x to the power of 8 plus the constant of integration c, such that the result that we want would be 5x squared plus 8 plus x to the power of 8, x to the power of 8 plus the constant of integration c. So this is up to number 3. Allow me to erase this part in blue such that we continue. So okay, now let's continue. Number 4, we want to find the integral of 2x to the power of 5 plus 7x over x. So what do we know? We know that with this quotient, we can actually simplify it, right? If we put each of the terms in the numerator separately under x, we are saying 2x to the power of 5 over x plus 7x over x. Then we can simplify this to get 2x to the power of 4 plus 7, such that with number 4, we're only required to find the integral of 2x to the power of 4 plus 7 with respect to x. So now let's integrate term by term. Right, this one, first of all, we are taking out the 2, then multiplying by the integral of x to the power of 4, which is say x to the power of 4 plus 1, 5, over 4 plus 1, which is also 5, plus 7. Right, now with this 7 being a constant, we know that it's 7. In actual fact, it's 7x to the power of 0, such that x to the power of 0 is just 1. So now we shall say 7 times the integral of x to the power of 0. That will be x to the power of 0 plus 1 to give us a 1, over 0 plus 1 to give us a 1. So we just get 7x. Then we say plus c being the constant of integration, such that the result that we want would be 2 over 5, x to the power of 5 plus 7x plus c, like that. Okay, so this is for number 4. Then for number 5, right? So from what we've talked about so far, with number 5 we have to expand, because we know that 2x minus 3 squared is the same as 2x minus 3, right, times 2x minus 3 there, and then of course with the bracket there, right? So let's expand this first. If we expand here, we get 4x squared minus 12x plus 9. Then we can find the integral for that. So with number 5, we're saying the integral of 4x squared minus 12x plus 9 with respect to x. This would give us, integrating term by term, the integral of 4x squared, we're saying 4 times the integral of x squared being x to the power of 2 plus 1, 3, over 2 plus 1, which is 3, minus 12 times the integral of x, this is x to the power of 1. So this will be x over 1 plus 1 to give us a 2, over 1 plus 1 to give us a 2, plus 9, remember 9 is 9x to the power of 0, such that the integral of x to the power of 0 would be x to the power of 0 plus 1 to give us a 1, over 0 plus 1 to give us a 1, then plus the constant of integration c, right? And then of course, continuing from here, we are saying that we've got 4 over 3 x to the power of 3 minus 2 into 12, we get a 6, 6x squared plus 9x plus c. So that's what we get for number 5. Then now moving on to number 6. Now with number 6 we can now easily integrate that because it's been expanded for us already. So allow me to erase this part in blue. Okay, so now for number 6, we are saying we want to integrate 3 minus x minus 2x squared. So for number 6, we are saying the integral of 3 minus x minus 2x squared with respect to x, right? Integral of 3x to the power of 0, we are saying 3 times x, right? Remember x to the power of 0 will just give us an x. Then minus, this is x to the power of 1. So the integral of x to the power of 1, we're saying x to the power of 1 plus 1, that will give us a 2, over 1 plus 1, that will give us a 2, minus 2 times the integral of x squared, we're saying x to the power of 2 plus 1, that's a 3, over 2 plus 1, that's a 3, then plus the constant of integration c. Further on simplifying this, we'll get 3x minus x squared over 2, minus 2 over 3x to the power of 3, plus the constant of integration c. Okay, and then now moving on to number 7. With number 7, we've got dy by dx being equal to 1 over x squared plus 5 raised to the power of 2. So first of all, what we need to do is that we could simplify this. We would actually expand, right? So now if we expand that, we get 1 over x to the power of 4, right? 1 over x to the power of 4 plus 10 over x squared plus 25. So that's what we get when we expand that. Such that if we raise these, right, if we put these into the numerator, for number 7, we are saying we want to get the integral of x to the power of minus 4 plus 10, so this is minus 4, plus 10x to the power of minus 2 plus 25 with respect to x, right? Then x, the integral of x to the power of minus 4, we're saying this is x to the power of minus 4 plus 1, we get a minus 3, over minus 4 plus 1, that's a minus 3, right? Plus 10 times the integral of x to the power of minus 2, we're saying x to the power of minus 2 plus 1, that gives us a minus 1, over minus 2 plus 1, gives a minus 1, plus 25, integral of x to the power of 0, that will give us an x, plus the constant of integration c. Further on simplifying this, we'll get 1 minus 1 over 3x to the power of minus 3, minus 10x to the power of minus 1, plus 25x, plus the constant of integration c. So that's how we do number 7. And then now moving on to number 8. So I shall erase this part as well for number 6 and 7. Right. And then moving on to number 8. Number 8, we need to differentiate 4 over the cube root of x. So now we have to simplify this denominator into something that will make more sense. So 4 over cube root of x, this is the same as 4, so let me say integral with respect to x. This is the same as 4 over x to the power of half. Sorry, this is the same as x to the power of 1/3, right? X to the power of a third, which is the same as 4x to the power of minus a third. If we had to put it in the numerator, so we want to get the integral of that with respect to x. So we are simply saying that 4 times the integral of x to the power of minus a third, that will be x to the power of minus a third plus 1, that will give us 2 over 3. Then over minus a third plus 1, that will give us 2 over 3. Plus the constant of integration c, and this would give us 4 times 3 over 2, x to the power of 2 over 3, let's see, which simplifies to 6 x to the power of 2 over 3, then plus the constant of integration c. Alright, so this is for number 8. This is for number 8. There you have it. And then for number 9, we need to integrate 2x times 1 minus x squared. So first of all, we can expand here. So for the expansion, what are we talking about? If we first expand this, then multiply by 2x, we'll be having the integral of 2x multiplied by 1 minus 2x plus x squared with respect to x, which you can now multiply throughout by 2x. For number 9, we're saying the integral of 2x minus 4x squared, then plus 2x to the power of 3. This is with respect to x. Okay, so now expanding what we have here, integrating what we have here, we are saying the integral of 2x, this is 2 times x to the power of 1 plus 1, 2 over 2, minus 4 times the integral of x to the power of 2, that's x to the power of 2 plus 1, 3 over 3, then plus 2 times the integral of x to the power of 3, that's x to the power of 3 plus 1, 4 over 4, plus the constant of integration c. This 2 and that will cancel, such that we've got x squared minus 4 over 3 x to the power of 3 plus 2 into 4 we get a 2, 1 over 2 x to the power of 4 plus the constant of integration c. So this is for number 9. Then for number 10, now with number 10 I would like to erase this part. Allow me to erase this part. Hope it's going to be now. Okay, so for number 10, we need to integrate 3 over the square root of x minus the square root of x to the power of 3. So as well, we need to remove these square root sides and probably put this in the numerator, such that it makes more sense. So what I'm going to do here for number 10, we shall rewrite this as the integral of 3x to the power of minus half, because we know this is 3 over x to the power of half. So it relates to 3 over x to the power of minus half minus x to the power of 3 raised to the power of half. And this is with respect to x. So we're saying the integral of 3x to the power of minus half minus x to the power of 3 over 2 with respect to x. Such that now for the integral, we are saying 3 times the integral of x to the power of minus half. That's x to the power of minus half plus 1. That gives us half over half. Then minus the integral of x to the power of 3 over 2. We are saying x to the power of 3 over 2 plus 1. That's 5 over 2 over 5 over 2. Plus the constant of integration c. So we're saying 3 times 2 x to the power of half. Then minus 2 over 5 x to the power of 5 over 2 plus the constant of integration c. This would give us 6x to the power of half minus 2 over 5x to the power of 5 over 2 plus c. Okay, so this is how we integrate number 10. Alright, so this was the basics of integration. Integration being the reverse process of differentiation. Please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.